Good day everyone. In CBSE 12, your first chapter is Relations and Functions. We are going to see the basics of relations today. For this relation and function, actually the very basic thing is which you have studied in your 11th standard, sets. I think you all remember that, isn't it? What is a set? I am not going very deep into it. A set is a collection of well defined objects. Okay, note that phrase well defined. You cannot just like that say some collection. It should be clearly defined. That is called a set. That is the basic for this relation, function, everything. Okay, now in life you have heard this word relation, especially in the family we say no, mother, father, daughter, son, like that. So many relations in family we speak. Other than this, in life if you think, everything is related to some other thing. For example, the demand and supply, they are related to each other. The price of any commodity is related to the demand, is related to the supply. Like this, we see so many instances in real life that things are related to each other. In maths, what is this relation means? You can consider certain examples like equal to, congruent to, greater than, lesser than, factor of, square root of. These are some examples of relations in maths. Okay, so now a relation means you will have two sets. The elements of one set will be related to the elements of another set, and you will define the rule of a relation. So that is called relation. Now, a relation can be expressed in four different ways. That is, the first way is you can write them as ordered pairs. Okay, this is one way of expressing a relation. The second one is you can have mapping diagram or arrow diagram. By that you can represent a relation. That is the second way. The third way will be you can write it as, that is, table of values. You can write some x values, you can write the corresponding y values. That is called table of values. Fourth one is you can represent it by a graph. In a graph you can plot the x values and y values. The x values belong to the domain set. The y values belong to the range set. I think I can give you a very simple example. Okay. Now let me consider this relation. Y is equal to 2x. A very simple relation I have taken. In the ordered pair I can say when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. Like this I can have. So this is the representation of the relation y is equal to 2x as ordered pair. In mapping diagram, I can have two things like two sets. Okay, I can have here 1, 2, 3. Here I can have 2, 4, 6. So I can map like this. Right? So now I will get y is equal to 2x. So this is x and this is y. Here the first elements are x, the second elements are y. Table of values means I will draw a tabular column like this. Okay. I can write x, I can write y. I can write x, I can write y, x, y. Like this. This is called table of values. Okay. In graph, I will take a graph like this. This is O, this is x and this is y. So I will have here 1, 2, 3. Here I will have 1, 2, 3, 4, 5, 6. Okay. So this is my 2. So this is 1, 2, 2, 4, 3, 6. Like this I can have. If I join, I will get a straight line. Not necessarily always a straight line, but here I am getting a straight line. So these are four different ways of expressing a relation. Okay. Here the first set of elements, that is the first element, we call them as the domain. The second set, which is the answer of the relation, that we call as range. So if you want to define any relation, you need three things. One is a domain set. The second one is the range set. And third is you need a rule of relation or a definition of a relation. You can define it in any way you want. Okay. So like this you can define. Now you should know the types of relations. Actually in your textbook only 3 types are mainly considered: reflexive, symmetric and transitive. Apart from this, they have just mentioned 2 trivial relations which are called void relation and universal relation. So only the 3 types are very important. But other than this, I am going to teach you one thing extra, which is called identity relation, because you should clearly know the difference between reflexive relation and identity relation. Okay. So let me start the types now. So the first I will take reflexive. Okay. Yeah, reflexive relation. For this, let me consider a small set so that it will be easy for you to understand. So I will consider A as a set which consists of the 3 numbers 1, 2, 3. Now, a reflexive relation means each element of the set should be related to itself. Okay? Every element of the set should be related to itself. That is called reflexive relation. So now the reflexive relation means I can write 1, 1, 2, 2, 3, 3. This is the reflexive relation. Suppose you just write 1, 1 and 2, 2, that is not reflexive, because for every element of set A, you should have a reflexive pair. That is only reflexive relation. Are you clear? Okay. Then let me move on to the symmetric. Okay. Symmetric relation means if some A is related to B, that implies that B is related to A. We can call that relation as symmetric. Okay, the other way is also true like that. I can give you a very simple example. Supposing you take a line AB is parallel to line CD. A line AB is parallel to line CD. Definitely line CD will be parallel to line AB. So I can call that parallel to is a symmetric relation. Now let me take this same example and explain to you. So I will consider A is equal to 1, 2, 3. Now the symmetric relation, if I have the pair 1, 2, I should have 2, 1. Now I can call this symmetric. You need not bother here whether the other pairs like 2, 3 or 1, 3 is there or not. For one pair, if it is present, you should have the symmetric pair. You can call this relation as symmetric. Or you can have another relation which consists of 1, 3, 3, 1, 2, 3 and 3, 2. This is also a symmetric relation. This consists of 2 sets of symmetric pairs. So it can contain 1 set of pairs or 2 sets or 3 sets, that doesn't matter. But you cannot have 1, 2 and if 2, 1 is not there, you cannot call it symmetric. I will give you that example also for you. You consider R2, 1, 3, 3, 1, 1, 2. Now, these two, you have the symmetric pair. For this one, you don't have the symmetric pair. So, definitely this R2, this relation is not symmetric. Okay, are you clear now? Reflexive means all the pairs should be there. In symmetric, for each particular pair, the symmetric pair should be present. Hope you are clear about these two, right? Now, let me move on to the third one, that is transitive. Okay, the third one is transitive. Transitive actually I can define as supposing some A is related to B and B is related to C, if that implies A is related to C, I can call that relation as transitive. Okay, follow it carefully. If A related to B and B related to C, both should be present. If that implies A related to C, you call it a transitive relation. Let me go to the same example. A is equal to 1, 2, 3. Okay, you consider the relation R. Now I have 1, 2. I have 2, 3. Now see, A related to B. B related to C. So if it has that 1, 3, that is A related to C, I can call it as a transitive relation. Is it clear? So if A related to B and B related to C implies A related to C. Here this one is A, this is B, this is B, this is C, this is A, this is C, right? So now A comma B, B comma C, they are there. So if 1 3 is there, I can call this relation as transitive. Okay. Now another small example which I can give for your easy understanding is, you all know 1 is lesser than 3. Okay, here the relation is less than. I know 3 is lesser than 6. Now I know 1 is lesser than 6, right? So this is A, this is B. This is B, this is C. This is A, this is C. So I can say less than is a relation which is transitive. Do you understand clearly? In this transitive, there is one extra case I can say, that is called a contradictory thing. That also you should know. That is, supposing in a relation A is related to B, but there is no element present such that B is related to C, you cannot check. No, how will you check whether A is related to C? In that case also, we call that relation as transitive. But this is a bit rare case, but you should know it. That is, if A related to B is present, that element is present. But B related to C, that element is not present in the relation. In that case, you have to say that the relation is transitive. Okay, so now you have understood the basic three which are given in your textbook as reflexive, symmetric and transitive. If a particular relation has reflexivity, symmetric as well as transitivity, we call that relation as equivalence relation. Okay, what is the name? Equivalence relation. Any relation which is reflexive, symmetric and transitive, you define it as equivalence relation. Okay, now let us check the other three also quickly. So now I will consider identity relation. Identity relation. Actually, you might be a bit confused between this and reflexive relation. So let me explain that difference clearly to you. Take the same example. A is 1, 2, 3, right? Now I consider one relation R1, which is 1, 1, 2, 2, 3, 3 and 1, 2. I consider another relation R2, 1, 1, 2, 2, 3, 3. Now, in both R1 and R2, you are seeing all the three reflexive pairs, 1, 1, 2, 2, 3, 3. Okay? So, definitely, R1 is also reflexive, R2 is also reflexive, there is no doubt about it. But if you look at R1, you have an extra element 1, 2. A reflexive pair can have extra element. So, this is reflexive, no doubt about it. But I told you, this is also reflexive. But here, there is no extra pair other than the reflexive pairs. So, this is an identity relation. Okay? So, I can call it this way. All identity relations will be reflexive relations. But all reflexive relations need not be identity relations. Are you able to understand it clearly? Or I can say it easily. If a relation consists only of the reflexive pairs and no extra element, it is called identity relation. If a relation consists of all the reflexive pairs and some extra elements, that is called just reflexive. It is not identity. Is it clear now? Okay. Then the two trivial things we will just see. One I told you is void relation or empty relation. This is called void or empty relation. That means definitely you won't get any element which has that relation. Okay, we can say for example, the set of all boys studying in a girls' school. Will there be any element? No. So that is an example of void or empty relation, right? Then the second trivial relation is universal relation. That is, it should be true for everything. Universal relation. You just consider some A which is 1, 2, 3, 4. The relation I am going to define as some two elements A plus B always greater than 1. Here, if you add any two numbers, definitely that is going to be greater than 1, you know, because 1 is the least possible number there. So if you add any number to it, definitely it will be greater than 1. So this is called a universal relation. So now these two, the last two, they are called trivial relations, not much of importance. So you should now know clearly about reflexive relation, symmetric relation, transitive relation. If all the three are present, you call that relation as equivalence relation. Okay? Then the identity relation, how it is different from reflexive relation. Identity relation is one which contains only the reflexive pairs and not even a single extra element. But a reflexive relation should contain all the reflexive pairs, plus it can contain any extra elements. Hope you are clear about all these things. So we will continue the rest in the next class. These are all the basic things which I wanted to teach you in this class. Okay? You can subscribe to the channel, and if you click the bell icon, you will be getting further notifications of the videos. Thank you for watching.